All right, so today we are going to learn how to solve systems of equations by elimination. Don't forget, hit like, hit subscribe, hit the bell. Uh, this is a variation of last week's notes. So for those that usually stare at your phones, iPads, and uh, devices during class, maybe you will actually go back and look at this later. All right, so using addition and multiplication. So the goal is to get basically you are becoming a mathematical hitman. Okay, you are trying to line up your x and make sure all your terms are lined up. X is in one column, y is in one column. Okay, here's our big key right here. We want to look for the same terms, different signs. Okay, and that will tell us which one of these that we can eliminate and get rid of it. Okay, uh, these kind of go a little bit quicker sometimes because it's usually, oh, I see this goes away, bing, bang, boom. Now, uh, there was a couple of questions yesterday, like, I understand in solving the steps of the equations, that doesn't bother me. It's when do I graph? When do I use substitution? When do I do this? Okay, that is a perfectly normal question right now. That uh, that is Monday's lesson about picking the best method. Okay, so now, now where it says all the terms lined up. Now this is we want our x's in one column. We want our y's all lined up. Okay, so our terms lined up. This is a yes. Okay, now again, eventually this is what you're going to be saying in your head. Okay, uh, this is this is not what. Okay, this is probably all right. Who's my English people? Who's my grammar people? Who's my grammar police people? Okay, is this correct grammar? No. Okay, great, because I'm a math person. All right, is there? Are there? Hey, listen. All right, I've got plenty of empty chairs. Look, I got an empty chair right here in the middle second row. I can put one of y'all if y'all don't quit sitting there trying to whack each other. Okay, keep your hands to yourselves. All right. Shh. So, do we have same terms, different signs? Yes. Okay. So, which is going to be the easiest to get rid of? Which variable, x or y? X. Okay. So, when we're doing this, when we're combining them, I don't like saying adding. Okay, because in each column we're probably going to add, we're probably going to subtract. All right. Again, the goal is to get rid of one of the variables. The goal is not to get rid of the constants. Okay, the constants we want, the variables we don't want. Okay, so our x's go away. Pew. Okay, and that's also fun to do. Now, exactly, because that's all we need in this class is more sound effects. So we have, all right, and let's see, -2 plus 3, this would be 1. Now, if we have -1y equals 1, well, what is -2 plus 1y? or negative 1y. Now, back to our original programming. So we can either multiply or divide right here. A lot of people, how many of y'all divide? Yeah, a lot of people would divide right here. I've been doing it for a long time. So, okay, so now we would get y equals negative 1 because uh, we cannot have negative y. We have to end up with y. Seth. Now, so we've solved. We've got y equals negative 1. Okay. Now, that's the easy part, right? Yeah, it seemed pretty easy. You're like, whoa, what's the other part? What's the other shoe has to drop? Okay. So now we need to find x. So we need to decide if we're going to pick the top equation or the bottom equation. It does not matter. A lot of people use the same one each time. A lot of people will just say, we're going to use the top. And that's just what they do. Okay. And the top equation was this. And it's very similar to what we did when it was substitution. Seth, do you need to go walk? It's understood to have a 1 in front of it. Yes, it does. All right. So now we plugged in our negative 1. This is negative 2 times negative 1, which is a positive 2. So x would be negative 4. Again, if we would have plugged it into the bottom, we would have got the same thing. Okay, it does not matter because remember, this is like we did with graphing. This is where these two things cross. Okay, this is when we were to graph them. These are, where these touch. You're going to get the same thing for x and y. Now, I will tell you this. People will use elimination when it looks like these first three. When it looks like the three that's on the back, they're like, not my fam jam. And that's okay because you have other options. All right. Okay, good. Got that written down. All right, scrolling down to number 2. All right, number 2. All right. Are the terms lined up? Do we have all the x's in one column, all the y's in a column? Yes or no? Yes. Okay. All right. Are there same terms, different signs? You think so? I would agree. I would say yes. Okay. Now, what's the easiest to get rid of? The x? Why is that? Ah. All right. Yeah, the y's will cancel out. That's the same terms, different sign. They cancel out. Okay. So, pew, they go away. So if I have three x's and two of them mysteriously disappear, I have one x and it's positive, so I can just leave it as x. All right. If I have 8 students and 5 of you mysteriously disappear, I have 3. Wow. That seems a whole heap easier than some of the other processes that we have done, right? Yeah. But it's just set up that way. Not all of them are set up nice and easy. All right. Now, what would you like to use? Would you like to use the top or would you like to use the bottom? I'm asking. Okay, I heard top from somewhere after there was a silence from forever. So 3x minus 2y equals 8. So we plug this in. All right. So 3 times 3 is 9. Minus 2y equals 8. Minus 9. Minus 9. Yeah. So we have minus 2y equals negative 1. So when we divide, we're either going to have this or 1/2. Okay, now that would be very difficult to see on a graph, correct? Yes. Okay, thank you, student. Especially if I was drawing it. Now, luckily, in the times that y'all live in now, until there's an issue with technology going down, y'all have options that's beyond paper. Okay? And first year we were open. Yes. All right. So when we combined right here, all right, so our y's canceled. All right. The question was, what is x equal 3? So we y's canceled, so we had 3x minus 2, so that was 1x. And then our constants, 8 minus 5 was 3. Yeah. So our first year we were open, I went to a professional development, which is like torture for teachers. And there was this teacher in front of me that was saying that they were making all their students graph on paper and it had to be exactly perfect. And the student was like, well, why do we have to graph on paper when we have calculators and we have computers that will do it for us? And the teacher said, well, when there's a nuclear holocaust, literally, that's what this teacher said. When there's a nuclear holocaust and none of the technology works, you will need to know how to graph on paper. I looked at that lady straight in her face. I said, ma'am, I said, I think if there's a nuclear holocaust, I think we got bigger issues than knowing how to graph a line on paper. She got up and moved from sitting in front of me. Some people just don't like common sense or being called out. So, I mean, it's something. All right. Number three. Are the terms lined up? No. All right. So, this one, it's okay. I mean, the top is good. It's in our X, Y constant or our standard form. Okay. All right. This bottom right here, I need to move this 3x over here, correct? So we would subtract 3x. All right. So we would have 3x plus 2y equals 3. So now, after we've had to manipulate it a little bit, okay? Sometimes you would have to do that. So they would line up. Now, do we have same terms, different signs? Oh yeah. This one's kind of a trick question. What's the easiest to get rid of? Both. Okay? You could have said X, you could have said Y. There was actually not a wrong answer right here, and this is why. Some of y'all are like, how is there not a wrong answer? What is 3x minus 3x? Okay? So this goes to 0, this goes to 0. Okay? Question. Does 0 plus 0 equal 0? Yeah, that is a true statement. Does anybody remember what we write when we have a true statement? Yes. Yeah. So this actually is IMS. Okay. So we actually have that. That will happen with some of these. These are my favorite. I love me some IMS because usually it means it's really easy. I love the fact that we didn't have a delay today for school and it was absolutely colder and the wind chill was colder than it was yesterday. Then we did when there was a delay. Loved it. Loved driving to school when there was 12 degrees. School's so much better when, like, seriously, Less is more, man. Like the only reason I'm like we could have actually been done with this lesson like 15 minutes ago, but I'm dragging it out so people can write it down. Have y'all ever been that person like you're trying to write it down and the teacher just keeps going? Yeah, I write slow. I read slow too. All right. What if you had to multiply to get same term, different signs? Okay. Now this is if you decide elimination is your fam jam. Like that is your go-to method. This is I love this method. Okay. All right. Again, you're like a mathematical hitman. All right. You're like, hey, you out. Okay. It's it gives me the warm and fuzzies. Okay. I know I'm a horrible person. I'm, I have a tattered past. All right. So if I'm regulated by medicine. All right. So let's look at this. In the blue, I have my X's. In the pink, I have my Y's. Now we're going to have to multiply either the top or the bottom to make one of these be have a different sign than the other one. What do you think is going to be what variable do you think is going to be the easiest to get rid of? Both, but what do you think is going to require the least amount of work? And this is where it gets tricky because a lot of people are like, I don't understand why you would say that. Okay, I'm going to say this. I'm going to say why. This is why. All right, so I'm going to leave the top alone. I'm going to take the top. I'm just going to rewrite it. Okay. Now this is when I start to lose people. They're like, oh no, more work. Right. You're like, you had me on the first few, and then you decided to do more work, and now I hate you. Okay. All right. So if I want this to be a negative 3y, if I want this positive 3y to be a negative 3y, what do I need to multiply that by? Yeah. So I would need to multiply everything by negative 1. Because remember, it's an equation, right? You got to multiply everything. Yeah, because, the people without internet that did drugs and math, they decided, hey, we got to do all this together. That's a weird Friday night. Hey man, you want to come over and do drugs and do math? Why not, man? Why did Ernest Hemingway decide to like drink a bottle of whiskey and write? All right, so x equals 1. Did I put a box? Oh, I did. I did put a box out there. Look at that. Or x equals negative 1. Now, same thing, I can use the top. All right. Yep. All right. So Now, again, some of y'all are like, well, how did you get to -1? I decided I wanted to get rid of the y. Okay? I decided, I said, I want to get rid of the y because I was like, hey, there's a positive 3y and a positive 3y. If I multiply one of these, I could have multiplied the top by -1 and got it to go away. You you have to look at what you're given. Okay? Some don't try to go. So many of y'all are going to try to go from this part right here to this part right here, and it won't work. Okay? Now, that's why I want y'all to look at this. Now, Hayden said to get rid of x. We could have got rid of x. We could have actually multiplied the top by -2 and got rid of x. I have some people that that's what they choose. They choose to get rid of x every time. Is there anything wrong with that? No. That's just what they do. It works for them. No, we're combining terms. Okay, do you see this over here where I multiplied it by all this at the bottom by -1? Yep. So I can get the y's to cancel. Remember, that was the goal to get one of the variables to go away. Yep. All right. So that was number 4. All right. Now, again, you look at it, you're like, okay, I want to get rid of you. And you decide how you're going to do that. Okay. I know there's got to be some type of video game or something that where y'all do some make some type of plan like this. All right. Let's look at number 5. Now, if we look at the x and y columns, okay, we have 5x and 2x. Here we have 6y and 3y. Okay. Now, if I decide to get rid of x, am I going to multiply one equation or both? Exactly. I'm going to have to multiply both. So, if we look at the y's, if we look at the y's, we have a positive 6y and a positive 3y. I think that we could get rid of the y's easier. Well, let's think about it. They both what? The both the x's equal 3? No, we just want one of them. We have to get totally rid of one of the variables. Because, Seth, if we just combine them like they are, none of the variables go away. Did you? Because what I had stated earlier when you had your head down is that the goal is to get rid of one of the variables. Because if we did it atlantically, it wouldn't work. You just, you just, you have to look at it a little bit more. They don't equal 3. All right. What could I do to this positive 3y to make it change to a negative 6y? Not by negative 1, by negative what? If I multiply, all right, so you want to get rid of x, Seth? Yes or no? Yes or no? Yeah, answer my question. Yes, because I want to do the easiest one to get rid of. If I try to get rid of, no, they're not. Okay, all right, Seth. All right, Seth. All right, you win, Seth. You win. You know more than I do, Seth. You ready? All right, Seth. You just made this 10 times harder. You ready? All right, here we go. Seth decided to get rid of x. Now I have to find a multiple that both 5 and 2 will go into. Now I got to find something. All right, so now I've got to change this to a positive 10x. So I have to multiply this whole thing by 2. Instead of doing it the easy way, I've got to do it this way. No, you just didn't trust me. You didn't trust the teacher that's been doing this twice as long as you've been alive. All right. So now, look, if this is a positive 10x, what do I have to make this to now? This has to be a what? Okay, think about it. I've got to get the x to cancel. This is a positive 10. I've got to make this into a. How is 10 minus 5 going to go to 0? I've got to make this go to a minus 10x. So that means I've got to multiply all the bottom now by negative 5. So now I have a multiple. I've got this x term where it will cancel now. Yeah, whoopsie. All right, so I got my x's to cancel. Pew. So 12y minus 15y is negative 3y. Now we would have got the same thing if we would have went my direction. Okay, just a little bit more multiplication. This would be 9. All right, so now we would divide by negative 3. So y would be what? I know a lot of y'all don't like to speak up in class, but y'all have calculators and stuff. Y'all can say what this is. And I know I'm not supposed to say it's very sad that y'all won't say the answer because, it hurts people's feelings. Again, I don't really care. It's negative 3. All right. So, which equation would you like to use to find x? The top or the bottom? Which one would you like to use? No, we've already found y. No, we got to plug it back in. We got to use either the top or the bottom now. No, fine. Okay, so let's do the bottom. Now, do I want to use the bottom after I multiplied or can I use it before I multiplied? Does it matter? Do I want to use it after I multiplied it by negative 5 or before I multiplied it? Yeah, you can use it after, but it doesn't matter. I can use it like this. This is what it looked like before I multiplied it. And I can still plug in because, that's what it was before I multiplied. Okay, so, all right, so we plugged in negative 3. Add 9. I just solved it the way you wanted to. But wait, I just spent 10 minutes doing it the way that you wanted to. I'll come back and show you separately when I'm not recording. And because because that's 10 minutes of and because I don't have time to like edit this after class. I wasn't feeling bad to begin with. I just really wish people would actually like I'm trying to help them. Well, I wouldn't do that. You may people that stare at me usually something bad happens to them. Okay, so let's look at our columns. Okay, so we want to pick again. Mathematicians by nature are lazy. Teenagers by nature are lazy. We are teenager mathematicians should be twice as lazy as a regular mathematician. So that's why we want to look for the easiest way. Okay, so that's why we want to look for the easiest variable to get rid of. Which variable would you like to get rid of? Both of these are equally easy because you're only going to have to multiply. Did you look at the problem? Okay. So what did you notice about the problem? Well, no. There is a light in the dark. There's not a shot. So let's look at it. This is a 6x and this is a 3x. Could you multiply 3 by something to make it be a negative 6? Okay. And this is a minus 2y, and then this is a minus 1y. Can you multiply minus 1 by something to make it be positive 2? Kinda. You can multiply something by this y to make it be positive 2, correct? Yeah? Well, negative 1 times negative 2 is positive 2. So you could do that if you wanted to. So that's what we're looking for. Can I change? No, you just weren't seeing it that way. There's a broader picture. Got to expand your mind, man. All right. So, what variable would y'all like to get rid of? X. I actually heard somebody say X. I'm ecstatic. I'm lots of other adjectives, but ecstatic is what we're going with right now. All right. So if we're getting rid of X, I need this X to be a minus 6X. So what would I multiply 3x by to make it be negative 6? Negative 2. All right. So I multiply everything by negative 2. All right. So this goes to 0. This also happens to go to 0. This goes, see, to 28. Does 0 plus 0, does that equal 28? No, this is a false statement. Just like a false statement of Mr. Jeffries does not have gray hairs in his beard. So this would be no solution. Ta-da! Okay. Look, well, I'm going to go back and show you. We're going to check that box and move on. All right. So don't forget, hit like, hit subscribe, hit the bell. Good stuff, good things. Roll Tide.